Have you ever wondered about the invisible threads linking our digital world? Submarine cables are the unsung heroes behind global internet connectivity, stretching across oceans and seas. But how exactly do these high-tech lifelines get installed beneath the waves? Submarine cables are specialized cables installed on the ocean floor to transmit telecommunication signals between land-based locations. They are crucial for global communications, enabling the high-speed transfer of data. The first submarine cable was developed in the 1850s, which linked England and France. Over time, the technology has advanced, with fiber-optic cables that were introduced in the 1960s. These cables are essential for internet connectivity, and power cables are used to connect energy sources in the sea to systems on land. As of 2023, submarine cables span approximately 1.3 million kilometers linking continents. But how are submarine cables designed to withstand extreme conditions in high-risk areas? Let's find out together. A submarine fiber cable system involves strong planning and design. Every stage guarantees that the cable can be properly installed, works reliably, and is capable of handling the challenges of the underwater environment. Engineers start the process by identifying the most efficient and safe path for the cable. It requires an accurate assessment of the environment and seafloor. To map the seafloor, high-resolution sonar scans are utilized to identify objects like tunnels. This information is important for planning the installation of undersea cables, which may be found at depths of 3,000 to 8,000 meters. For example, the Maria cable is a long undersea cable that links the United States to Spain. It stretches about 6,600 kilometers and goes as deep as 4,000 meters underwater. To preserve the cables, special precautions are needed in areas at risk for earthquakes and other seismic activities. In addition, human activities such as fishing and shipping are monitored to prevent cable damage. An environmental impact assessment, also known as an EIA, ensures that laying cables will not harm aquatic life. Some cable installations modify their routes to avoid sensitive areas such as coral reefs, which are vital for endangered species. This installation usually needs approval from both national and international organizations and requires careful observance of environmental regulations. Let's get into how these cables are made. Submarine fiber cable manufacture is a highly technical procedure that combines modern technology with skilled engineering to build cables that tolerate the extreme conditions. Long-distance data transmission uses optical fibers and submarine cables, which are protected by several layers. These protective layers include tough plastic, steel wires, and moisture barriers to ensure the cables remain strong and secure underwater. The process begins by removing optical fibers from silica glass protorods, which are heated to 2,000 degrees Celsius to form thin fibers with a diameter of 125 micrometers, slightly thicker than a human hair. The fibers are covered with a protective coating after they're made to shield them from harm and increase the effectiveness of light transmission. It also increases mechanical strength as well. A fiber bundle is a large structure composed of numerous optical fibers, often containing hundreds of individual fibers for high-capacity cables. The transatlantic cable frequently uses up to 96 fiber pairs in a single bundle, each capable of carrying 100 gigabytes per second or more. The core strength element of a cable, often made of steel or Kevlar, provides the main structural support. This core keeps the cable's shape and quality during installation and use. Additionally, steel wires are then wrapped around this core to enhance durability and protect against damage. Extra layers of steel wire protection are added to cables in risky places, such as shipping lanes or shallow oceans. For example, the Asia-America Gateway cable, which is in a high-risk area, has a layer that can be up to 5 millimeters thick. Fibers inside the cable are protected from physical damage and electrical interference by many layers of insulation, which usually consist of polypropylene and polyethylene. A thick outer layer covering protects the entire cable from external factors. The SCA-ME-WE5 cable includes additional coatings on top of its polyethylene sheath to increase dependability. Once the cable is made, it needs to be transported and laid on the ocean floor using specialized vessels. The most active vessels used for such operations are Skagerrak and CS Sovereign. These boats carry large spools of cable and have advanced onboard. It's carefully wrapped around large drums to avoid twisting or tangling that could cause damage. As the boat moves along its route, the cable is gradually released and laid down on the ocean floor. The crew monitors the process closely, adjusting speed and pressure to ensure a smooth and secure installation. The cable innovator used in the North Atlantic Loop project can lay up to 6,000 kilometers of cable. In shallow waters, the cable is laid directly on the seafloor, which is straightforward but may require extra safety measures in busy or hazardous areas. During the Asia-America Gateway project, a digging machine was used to lay the cable as deep as 2,000 meters in certain places. It's important to keep an eye on the cable laying procedure to make sure it's done correctly and to modify it as needed. The cable laying ship has tools to check and control stress so the cables don't get damaged. Modern instruments such as GPS are used to track the cable's location and make sure it stays on the planned route. Moreover, in some areas, the cable is secured to the seafloor with weights. This method helps keep the cable in place, reducing the risk of it shifting due to ocean currents or being disturbed by human activities. By keeping the cable stable, it won't be easily moved by sea currents or disturbed by people, which helps it work reliably for a longer time. After laying the cable, the ship faces a number of challenges. These include logistical, safety, environmental, and technological issues. Extreme weather, like storms and large waves, can significantly impact the installation process. Unstable waves can make it difficult for cable-laying ships to remain steady, which affects how accurately the cable is placed. For example, during the transatlantic cable installation, severe weather led to schedule changes and delays. At great depths, such as 8,000 meters, technical difficulties arise from extreme pressure and the need for specialized equipment. Deep-sea cables must be built to withstand these harsh conditions. Concrete mats are laid over undersea wires to keep them secure and protect them from external influences. These mats consist of precast concrete blocks that are usually created like interlocking tiles and protect the cables from activities such as trawling and anchoring. In the North Atlantic Loop project, concrete mats were used in shallow waters to protect the cable from potential damage by fishing gear. In certain circumstances, dirt or stones are poured over the wire to provide a natural barrier. This strategy is used when mechanical protection is difficult to implement or more weight is required to keep the cable stable. Saddles and brackets are used in underwater cable installations to attach the cable, especially when it encounters barriers or requires extra support. For example, saddles were used to stabilize the Hibernia Express cable when it was installed across underwater terrain. Furthermore, in cases where mechanical protection is impossible or extra weight is required for stability, gravel or boulders might be laid over the cable to form a natural protective layer. After undersea cables are installed, they need regular maintenance to keep them working properly. Although this process can be time-consuming and expensive, it is essential to maintain the flow of data and communication around the world. Without them, you wouldn't have this video. So what do you think? And don't forget to like and subscribe.